Hi, welcome to my channel, The Magic of Math. Today I have a video for you. It's part A of two videos, part A and part B, and this is reviewing for or preparing for a grade 8 state or end of year assessment. So the questions that you will see in this video are from the MCAS 2018. They're the released questions that are no calculator. So no calculators permitted today. So these questions represent what every grade 8 student should know and be able to do by the end of grade 8. They are representative of the Common Core grade 8 standards. They are specifically from the state of Massachusetts state end of year exam for grade 8 students from the year 2018. It is half of the released questions. It is the questions that students are not allowed to use a calculator on. Part B will be the calculator questions. Noting that state of Massachusetts follows the Common Core standards, so really for any state assessment or any state you live in or any end of year assessment you're preparing for, these questions aren't specific necessarily to Massachusetts. They are nationally Common Core grade 8 standards. Here is half of the reference sheet that Massachusetts students are allowed to see during any question of the exam. They can pull this up. They have these conversions that we do not expect students to memorize, that they can always reference the sheet or look them up. They don't have access to the internet during the test, so we provide that to them on this reference sheet. The bottom half of the reference sheet provides formulas that we don't expect them to memorize: area, circle formulas, volume formulas, and the Pythagorean theorem are provided to them. So again, I will bookmark this with a chapter in the video so that you can refer back to it when you're solving problems independently today, and students can access it on any question they're on. Now, how we're going to proceed through this video today, or how I think you should do it, or how I ask my students to do it, is I'm going to read the question to you and ask you to pause, and I would like you to pause the video, do the work on your own, and then come back to see my worked out example and see how you did. So the first question we have here is, what is 2.03 times 10 to the 11th written in standard notation? Go ahead and pause now and come back when you think you have your answer. Welcome back. So this is a power. We are going to rewrite it in standard form, and it means that you need to move the decimal point 11 spaces to the right. Because this is a positive exponent, it's going to move to the right and represent a very large number, a number larger than 1. So we're going to count our decimal places. 3, 6, 9, this is 10. So it's 10, not 11. We have 3, 6, 9, 10, 11. So here we have it, but I'm going to show you the rest. We have 3, 6, 9, 12. Here we have 3, 6, 9, 12, 13. So our answer is B, because this is the one that represents moving 11 decimal places. Two rectangles and some of their dimensions are shown. The rectangles are similar. What is R, the length in feet of the smaller rectangle? Go ahead and pause now and come back to check your work. Welcome back. So the first thing we need to note is they're telling us that these rectangles are similar. Similar figures are figures that have corresponding angles that are congruent and corresponding sides that are proportional. We know that all the corresponding angles here are congruent because they're both rectangles, and all rectangles have 4 90-degree angles. Corresponding sides are 6 feet to R, the corresponding from one rectangle to the other rectangle, not 6 feet to 4.5 feet. There's no relationship here as far as similar figures between the same sides of a same rectangle. Then the other pair is 4.5 feet to 3 feet. So the longer side of the rectangle to the longer side of this rectangle, shorter side to shorter side. Now we know they're proportional, so we can write a proportion. Our first ratio is 6 to R, 6 to R, 4.5 to 3. So you can see I have larger rectangle to smaller rectangle. Cross product, 4.5R equals 6 times 3, which is 18. divide both sides by 4.5, and r is equal to 4, so my solution in units is 4 feet. Jacinda determined that the diagonal of her laptop screen is 2 square root of 42 inches long. What is the approximate length to the nearest inch of the diagonal of her laptop screen? Your turn. Pause and come back when you're done. Welcome back. So what I'm going to do is focus on the square root of 42 first. This is 2 multiplied by the square root of 42. So I'm going to approximate the square root of 42, reminding you cannot use a calculator. So I'm starting a number line, and then I'm going to make my square roots above it. So the square root of 25 is 5. Square root of 36 is 6. These are my perfect squares. I know that the square root of 42 is in between, somewhere in here, between the square root of 36 and the square root of 49. So go square root of 37, square root of 38, square root of 39, and you would keep going until you got to the square root of 49, and you would eventually get to the square root of 42 in there. So let's blow this part up, because we only need to focus between 6 and 7. So we know that the square root of 42 is in between these somewhere. It is 6 away from 36. 36 plus 6 is 42. 42 plus 7 is 49. So it's not quite halfway, right? It's closer to 36 and further away than to 49. So I'm going to estimate this to be about 6.4. I'm reminding you that this is 2 multiplied by the square root of 42. So my diagonal is 2 multiplied by about 6.4. When I do that, I get 12.8, and they asked us to go to the nearest inch. So the nearest inch would be 13 inches. Which of the following is an irrational number? Pause now and come back when you're ready. Welcome back. So I'm going to review each of these 4 choices with you. So the square root of 0 is equal to 0, which is rational. So remember, 0 is a real number that is rational, it's an integer, and it's a whole number. So it can't be A. B is the square root of 3, which is a non-perfect square, and therefore is irrational. So we have our answer, but I'm going to keep going so that you can understand why C and D are not the answers. Since the decimal in part C is repeating, this would be 1.363636, it can be written as a fraction and it's irrational. And I'm going to give you a link to watch how to turn a repeating decimal into a fraction. It's quite magical. Then D, we have negative 0.19. Since this is a terminating decimal, meaning it doesn't repeat or go on forever, it can be written as a fraction. It can be written as negative 19/100ths. So therefore, it's rational. So our answer is B, because the square root of 3 is a non-perfect square. It is the irrational choice. Here we have a question for you. Which of the following equations represents a linear function? Go ahead, your turn. Pause. Come back when you're ready. Welcome back. So first we need to review that a linear function is a function that can be written in the form y equals mx plus b, where m is the slope and b is the y-intercept. We call this slope-intercept form. So now we need to go through and check which ones of these choices will satisfy this. So we know that the variable cannot have an exponent other than 1. So in this form, y equals mx plus b, there's an invisible 1 there. This equation has a variable of 2. So therefore, this is not linear. In high school, you'll learn this is a quadratic function. C, the variable cannot be the exponent. This is an exponential function, which you'll again learn about in high school. But because x is the exponent, we know it's not linear. It will not be a line. And D, if I distribute the x times x is x squared, and therefore the exponent is not 1, and it cannot be a linear function. So because I can rule all of these out because of the exponents, I know that A has to be my linear function. And just to review, x divided by 12 is the same as 1/12 times x. So my slope is 1/12. My y-intercept b would be 0. So there you have it. Your correct choice would be A. Here we have a table that represents a linear relationship between x and y. Based on the linear relationship in this table, what is the value of y when x is 4? Go ahead and pause and come back when you're ready. Welcome back. So the first thing I'm going to do is identify the relationship. So with the x values, -6 plus 2 is -4. -4 plus 2 is -2. -2 plus 2 is 0. I'm going to add now some rows to my table so that I can continue my pattern. 0 plus 2 is 2. 2 plus 2 is 4. They are asking me to find the y value when x is 4. So I know that x is 4 here in my pattern. So let's go to y. Y over here is increasing by 1. -3 plus 1 is -2. Plus 1 is -1. Plus 1 is 0. And keep going down. 0 plus 1 is 1. And 1 plus 1 is 2. So we know that when x is 4, y is equal to 2, which is B. Here we have an open response question where students are expected to show or explain how they got their answer. Would not be graded by a computer. It will be hand corrected by a human being. So it's very important students get graded on a scale from 0 to 4, and they are not given credit if they don't show or explain. So a student wrote the equation shown, x to the y equals z. And part A is asking you, what is the value of z in this equation when x is 3 and y is 4? Go ahead and try, pause, and come back. Welcome back. So the first thing I'm going to do is rewrite it with x replaced with 3 and y is 4. So now I have 3 to the 4th. Remembering you can't use a calculator, so I'm going to write it out. This is 4 3's multiplied together. So 3 times 3 is 9, 3 times 3 is 9, and 9 times 9 is 81. So there you have it. 3 to the 4th is 81. Part B. What is the value of x in the equation when y is 3 and z is 125? Don't forget to show or explain. Pause and come back when you're done. Welcome back. So I'm going to rewrite this so that y is 3 and z is 125. And there's two ways to look at this. If you want to find the value of x, we can find the cube root of both sides, or you can ask yourself, x multiplied by itself 3 times must equal 125. So what number, when multiplied by itself or cubed, is 125? So I show my students how to make an organized list to see the pattern of perfect cubes. So 1 cubed is 1 times 1 times 1, which is 1. 2 cubed is 8. 3 cubed, 3 times 3 is 9, times 3 is 27. 4 cubed, 64. 5 cubed, 125. So we know that x has to be 5. Here's part C. The student rewrote the equation as shown. The y root of z equals x. Is the value of x a rational number when y is equal to 2 and z is equal to 2? Don't forget to explain. Pause and come back. Welcome back. So I'm going to rewrite it. So we have y is 2 and z is 2. Noting that we don't see this index here of 2 when it is 2. It's invisible when it's 2. We can rewrite this to be the square root of 2. Same thing, same value. The square root of 2 is not a perfect square. Therefore, it is irrational, and the answer to our question is no. Last part. The student rewrote this equation with an integer value of y and an integer value of z that can make the equation true when x is equal to 8. So you need to find a value of y and z such that x will be equal to 8. Don't forget to show or explain your work. Pause and come back. Welcome back. So when we're looking at it this way, we know that 8 times 8 times 8 is 512. So the cube root of 512 is 8. So when y is 3, z has to be 512. Now, that's one solution. There is another option. You could have said, well, 8 times 8 is 64. So the square root of 64 is 8. So you could have answered that when y is equal to 2 and z is equal to 64, x will be 8. So either of these, you didn't need to have both, you just needed to have one. Next question. Which pair of steps can be used to completely solve this equation? 4x minus 5 equals 17. Pause now and come back when you're ready. Welcome back. So I'm going to go ahead and just solve this equation before I even look at my answers. If I were going to solve this, first I would add 5 to both sides to isolate the variable term, creating this 0 pair right here and leaving me 4x equals 20. My next step would be to divide both sides by 4. And solution of x equals 5. Check it. 4 times 5 is 20. 20 minus 5 is 15. So this checks. So add 5 to both sides, checks with my first step, then divide both sides by 4, checks with my second step. So now I don't even need to second guess any of this because I showed my work. I'm very sure of my answer of A. Which of the following represents the linear relationship with the greatest rate of change? Pause now and come back when you're ready. Welcome back. So the greatest rate of change, when they talk about rate of change, they're talking about the slope. So in the first question, the first choice, our rate of change is our slope, which is 2. Y equals mx plus b, m being the slope. Part B, we need to find the ratio of the change of y over x. Negative 13 to 8 to negative 3 to 2, this is increasing by 5. And the change of x is increasing by 1. So the ratio of the change in y over the change in x gives me a slope of 5. Also, slope can be read as rise over run. So if it rises 9 for every 3 units to the right, 9 over 3 is equal to 3. So this function would have a slope of 3. Now we have a graph, and we're going to go from one point to the other. I'm going to rise 1, 2, 3, 4, and run 1. So my rise over my run gives me a slope of 4. So my greatest rate, which would give me my steepest line, is choice B, 5. This diagram shows a cylinder that has a radius of 3 inches and a height of 5 inches. What is the volume in cubic inches of the cylinder? Go ahead and pause and come back when you're ready. Welcome back. I'm going to start with my volume formula, and that is volume equals pi r squared h. So the area of my base, which is a circle, pi r squared, times the height of the cylinder. So in this case, the radius of my circular base is 3. So r squared, 3 squared, times the height of my cylinder. It connects the two circular faces, so the height is 5. Now I just need to multiply. 3 squared is 9. 9 times 5 is 45. And they left it what we call in terms of pi. So you don't multiply by 3.14. So our answer is C. Which of the following is equivalent to this expression? 7 squared times 7 to the negative 4. Pause now and come back when you're done. Welcome back. So I have, when a product of powers has the same base, they have the same base of 7, we're going to, and being multiplied, product, we're multiplying, we're going to add the exponents. So I have 7 squared plus to the negative 4. So 2 plus negative 4 is negative 2. Now I need to understand that this is not in simplest form when I have a negative exponent, and a negative exponent means to divide. I'm going to rewrite as the reciprocal with a positive exponent. So we're going to flip this down to the denominator and makes the exponent positive. So it's 1 over 7 squared, which is equivalent to your choice B. And there you have it. That is half of the review for 1 year of the 2018 MCAS assessment where no calculator was allowed. I hope this helped you prepare for whatever assessment you're getting ready for, and that you will come back and join me at the Magic of Math. Please subscribe to my channel, give me a thumbs up, and I hope you all have a great day.